Good afternoon, ladies and gentlemen, and welcome back to the 2003 Euclid Math Competition. We're on question number 2. Hopefully you've downloaded the contest and had a chance to take a look at not just this question, but all the questions, giving them a good shot. So let's take a look at what question number 2 says. 3 parts, 2 light bulbs, and 1 written final answer with that lazy goat and the helicopter question. Alright, so 2a. If x is between 0 degrees and 90 degrees, completely reasonable, and 3 sine x minus cos 15 degrees is equal to 0, what is the value of x to the nearest tenth of a degree? Okay. Well, I can't think of an exact way to do this. So let me just think here. Cosine of 15 degrees. That is an exact thing. That is an exact one. That's root 6 plus root 2 over 4, something like that. You can figure out cosine 15 exactly by using cos of a minus b is cos of a times cos of b plus sine a sine b. So we could get an exact form for cos 15 degrees. And we rearrange the equation divided by 3, but I suspect we won't get an exact form for sine x. We'll get an exact form for sine x, but I don't think we'll be able to work our way back to getting x. Because they're asking us about nearest tenth of a degree. And to me that suggests rounding, and then that suggests using our calculator. Okay? So this might just be a question where we have to put our hands up and say either I brought my calculator or I didn't. Let me give it a try for a moment, however, just seeing if I can do some exact form stuff and see if I can think of anything. So 3 sine x minus cos 15 degrees equals 0. I'm not going to spend too much time on this one, so if I can't see anything to do right away, then yeah, we'll just use our calculator. But I do try and think of ways to do things without using calculators. Just because not everyone remembers to bring their calculator all the time. That happens. Okay, so I can figure out cos 15. I don't know exactly what it is off the top of my head. I think it's root 6 plus root 2 over 4. But we'll go, it's not one of the ones I always have memorized. Sine 30, 45, 60, those are good ones to know. And same with cosines and 0 and 90 as well. Those are good ones. And knowing how to get some of the other ones with these formulas, okay, so that's 1 over root 2, and cosine of 30, that's root 3 over 2, plus 1 over root 2, and sine 30 is 1 over 2. Okay, so it looks like we have root 3 over 2 root 2, plus 1 over 2 root 2, and to get a common denominator, well, we've got a common denominator, but to get it to be a nice integer, we'll multiply top and bottom by root 2, and we'll get a 4 down there. So yeah, it is root 6 plus root 2 over 4. Okay, so that's what cos 15 degrees is. And we know that 3 sine x is equal to cos 15 degrees if we just rearrange that. So if we divide both sides by 3, then we get our sine x is this value right here. And this isn't jumping out at me as any particular value. So is there anything I can do here? I don't think there's anything I can really do here. There we go. We're at some angle here, and we've gone up root 6 plus root 2 over 12. That's our sine. That's the height we're talking about here. We can definitely work out our cosine, because it's on a circle, and the ratio there would give us the tangent, but none of that's working our way back to getting the x value, and this isn't one that I recognize. Maybe it is something exact, like 22.5 or something, but I can't think of it. It's not jumping out at me. So what I'm going to do is I'm going to say, well, got to use my calculator at this point. So I'm just going to do sine inverse of, I happen to have the exact form right here, so root 6, oops, where's my back button? Root 6 plus root 2, all divided by 12, and then sine inverse of that. And that's the best I can do. Make sure your calculator is set to degrees before you do that, otherwise you'll likely get the radians. But most calculators are set to degrees already, and I'm getting 18.7824 and so on. So we just have to take that, and they wanted it to the nearest tenth of a degree, so 18.78 we round up. Okay. So we round up and we get 18.8. And that's the best we can do here. There's nothing really more to say about this. It was a light bulb question, so we could have expected that it was just going to be quick calculator work, especially because, it's question number 2. We shouldn't be putting a lot of effort into question number 2. I put way too much effort in there, especially because I had my calculator handy. But I do try and find ways to do it without a calculator, if I can. Maybe one day I'll try and do a whole contest without using any calculator and see how far I can really get. Alright, question 2b, that's another light bulb, and so maybe it'll be another quick calculator question, who knows. In the diagram, triangle ABC is right angled at B, just as they have shown, and AC is 20. If sine C, okay, we're talking a lot about sine and cos, I'm going to expect in C to have to do some trig as well. In fact, I can even see some angles down here. Anyway, if sine C is 3 over 5, so 3/5, what is the length of BC? Okay, so this relies on our knowledge of right-angled triangles and trigonometry, and the first thing that should come to your mind when I say right angles and trigonometry should hopefully be SOHCAHTOA, that the sine of an angle is the opposite over the hypotenuse, the cosine of a given angle is the adjacent side length to that angle divided by the hypotenuse, and the tangent is opposite over adjacent. Okay. So that's nice trig ratios for any right angle triangle at all. So let's redraw our picture. First of all, just a little refresher, in case you've forgotten it. If I have a right angle triangle, I have an angle theta that I'm interested in, I have my hypotenuse, I have O, the side length opposite the angle I'm interested in, and A, the side length adjacent to it, but that isn't the hypotenuse. Then we get SOHCAHTOA, and S for sine of theta is opposite over hypotenuse. Cosine of theta for the ka is adjacent over hypotenuse. So we can work out the sines and cosines from these ratios, or we can work out these ratios from the sines and cosines. And finally, TOA, tan, is opposite over adjacent. Okay. So what do we got in our situation? We've got right angle here at B, and I cannot remember what side C was, but I think it's ABC. Usually they go clockwise. So our angle of interest here is C. Okay, and we are told, so if we mark everything from this angle C, here's our hypotenuse. BC is going to be the adjacent one, and AB is going to be the opposite one. So let me just double check that I do have these guys arranged properly. Yeah, ABC. And we're told that sine C is 3 over 5. And AC is 20. So H here is 20. So sine C, we're told that that's 3/5. But SOHCAHTOA says that sine C means that the opposite over hypotenuse is going to be 3/5. So if we do a little cross multiplication, we get that 3 times the hypotenuse is going to be 5 times the opposite side length AB. Now we weren't asked for AB, I don't think. We were asked for BC, so that's the adjacent. Okay, but it's a Pythagorean triangle, so if we can work out H, which we've already got, and O, which we'll get in a moment, we can use Pythagoras Theorem to get A. Perfectly sensible. You could have done. You could have also figured out cos c as a ratio. You'll get 4 over 5 if you do a tiny little. If you use the sine squared plus cos squared is equal to 1 rule, that'll also get you a way to do it, and then you'll get a over h directly. But either way, 3 times h, that's 3 times 20, that's 60. 60 divided by 5, that's just going to be O, and so that's 12. So now we know that this side length over here is 12. A squared plus O squared is equal to h squared. So that's a squared plus 12 squared is equal to 20 squared. Or a squared is, what's 20? 20 squared is 400 minus 12 squared, that's 144. We brought the 12 squared over to the other side. And when we work this out, we get, I think, 256. But I'm going to double check it because I got a calculator handy anyway. Yep, 256, and we recognize that as 16 squared, hopefully. If not, your calculator will again spit it out. So we were asked for BC, as I recall. BC, and that is the adjacent side length to angle C. And that's 16. Very nicely done. And now we're on to the written questions, so we have to be a little more careful. We have to justify everything, and we have to, if we're being nice, write in nice, clean, clear sentences. Okay? Show our work in a logical manner. Do things like write 1, 2, 3 to show our steps and where they're happening, especially if we tend to write all over the page. Okay, C. A helicopter is flying due west over level ground at a constant altitude of 222 meters. Okay? And at a constant speed. A lazy stationary goat, which is due west of the helicopter, takes 2 measurements of the angle. And a goat that can take measurements of an angle, that is not a lazy goat. That is a mathematically inclined goat. So it takes 2 measurements of the angle between the ground and the helicopter. The first measurement the goat makes is 6 degrees. And the second measure he makes 1 minute later, that's probably going to be key, is 75 degrees. If the helicopter has not yet passed over the goat, as shown, how fast is the helicopter traveling to the nearest kilometer per hour? I think if I remember this question correctly, the answer is something like 123. But I'm not entirely sure. It's been over a decade. Well over a decade. Okay. So, things to take note of. We're asking for a speed. And so speed typically is done with distance over time. So if I know the distance the helicopter traveled in a certain time length, I divide those two and I get the speed. And we know that it's going to be going at a constant speed. We're told that in the question. Other things I make note of are the units. We're being asked for nearest kilometer per hour, but our measurements, our length, the only length we've got so far is 222 meters. That's not kilometers. So we can either do everything in meters and then do meters per second or something like that, or meters per minute, because they give us the only time length they talk about is 1 minute later. So we'll probably end up with something in meters per minute and then need to convert that into kilometers per hour. So we'll talk a little bit about that in a moment too. But other than that, questions, parts A and B have prepared us that we're probably going to need to be doing some trig, likely of right angle triangles. I say likely of right angle triangles, 1, because that's easiest, and that is what we saw most recently in 2B. But also because if you take a look at our picture, a level ground and the helicopter being directly above, that's going to make a right angle. Okay, so let's redraw our picture, maybe a little nicer with less goats and helicopters and more just dots that we're interested in. Okay, so goat is down here, G for goat. Helicopters are up here and up here. This is the first time. That the goat sees the helicopter, and we know that that is an angle of 6 degrees. And then the second time the goat sees the helicopter, is it a full 75 or is it 75 more? I can't remember what the diagram said. 75 degrees, okay. 75 degrees. Okay, so we've got right angle triangles and angles in here. And we know we've got 222 meters both times for the opposite side length to our angle. Okay. And we know the helicopter moves from this one to this one in 1 minute. So he goes this distance in 1 minute. If we could figure out this distance, we'd be all set. So how are we going to figure out this distance? Well, I noticed that it's the adjacent angle, the adjacent side length to the 6 minus the adjacent side length to the 75. So if I can work those out, I'll be all set. Okay. So how are we going to do that? Well, it'd be really nice if we could just figure out the side lengths to these triangles. So how about we take a look at them in turn? Here's our 6-degree one, and we know we've got 222. So I'm going to just write a 6 here for my angle. Actually, no. The reason I didn't want to do that is because the 0 was kind of the O was kind of big. I didn't want to be confused and think it was 60 again. All right, so we got 6 degrees here. So if I know the opposite length, so if I write out my SOHCAHTOA, I want the adjacent length. Well, involving the angle, the opposite, and the adjacent, there's only one that does that, and that's SOHCAHTOA, the TOA. So, tangent of 6 degrees is our opposite over our adjacent. Okay. So how do I just get A out of here? Well, if I multiply on both sides by A, I'll get A times tan of 6 degrees is 222 meters. So A by itself will be 222 meters over tan 6 degrees. And now I've got the large blue length on the ground. How about the red length from our red triangle? 75 degrees. Still looking at 222, and we still want that adjacent length. We'll call this adjacent 1 and this adjacent 2. Just so we don't get confused later. Okay. So, by the exact same reasoning, we're going to get our adjacent side length number 2 is tan 75 degrees. So the distance the helicopter goes in 1 minute is A1 minus A2. So that's 222 over tan 6 degrees minus 222 over tan 75 degrees. Okay, great. I don't think I want to simplify that right now. What I could do, and what I recommend you don't do, but what we could do is we could figure out what tan 6 degrees and divide 222 by that. We're going to get some decimal on our calculator. And then same thing with 222 over tan 75 degrees, and we could subtract the 2. But depending on how we do that, we're eventually going to have to cut off the decimal places just because the calculator eventually cuts them off, right? But if you start cutting things off, and depending on how quickly you're cutting off, are you cutting off the nearest meter, or are you giving it 3 decimal places? Depending on what you do, you might start introducing rounding errors, and you might get the wrong answer. You might be off by 1 kilometer per hour in the end or something like that. So I try and keep things as exact as possible. Now, tan of 75 degrees, I think we can actually get an exact value for that, but tan of 6 degrees, I think I'm out of luck. So I think I'm going to leave it like this for a moment, and just maybe call it capital A, okay? Give that a name, capital A. So let A be minus 2. The difference between those adjacents. So that's the value we're going to look for. The speed of the helicopter, this constant speed, is the distance A over the 1 minute. Okay, and A is, by the way, in meters. So we'll get meters over minutes here. But divided by 1 minute, this is just going to be, so we have A meters up here. Dividing by 1, A divided by 1 is just A, so this is just going to be A meters per minute. Okay. But the question asks us for kilometers per hour. So we need to convert from meters per minute to kilometers per hour. Okay? So if I've got something in meters per minute, and I want it in the end to be kilometers per hour, I need to get rid of this meters and introduce kilometers. So I want to divide by meters and have kilometers on the top. That way when I multiply, they're going to cancel out. So how many kilometers per meter are there? Well, there's 1,000 meters in a kilometer. So that means there's 1,000 kilometers per meter. Okay, I want to get rid of minutes and introduce hours on the bottom. Because ultimately I want to be left with kilometers per hour, so hours needs to be on the bottom. So we need to multiply by a constant here. How many minutes are there per hour? There's 60 minutes per hour. So this will give us 0.06 times A kilometers per hour. Alright, let's double check that. 1 divided by 1,000 is 0.001. Multiplied by 60, we get 0.06. So, to convert from meters per minute to kilometers per hour, we multiply by 0.06 kilometer minutes per meter hours. If you want to be really fancy with your units. But the point is just multiply A by 0.06. And this should give us our answer. So now I'm going to bring back in the actual value for A and do my final calculation here. I can take out a factor of 222. Now it's just 1 over tan 6 degrees minus 1 over tan 75 degrees. Okay. Well, 0.06 times 222, that's 13.32. And now, here's where we have to sort of really round 6 degrees, tan of 6 degrees. And then, where's my reciprocal button? There it is. Minus tan of 75 degrees inverse. So I'm getting a difference of 9246415. I'm just going to keep that in there as much as possible. And that's what I get. Now, I'm just going to double check that and see if it makes sense. Tan of 75 inverse is 0.2. Basically 0.26. And tan of 6 inverse is basically 9.51. So 9.51 minus 0.26. Yeah, but getting a 9.24 works, so I did enter everything in on my calculator correctly. Great. So now I need to multiply these two values. So 13.32 times 9.246415, and there's some other junk in there if you want it. You really judge how much, but more decimal places, the better. And I get 123.1622 and some other stuff. And they said round to the nearest kilometer per hour. And that is 123. And I'm just elated that after all these years, my memory really serves me. 123 kilometers per hour, and that is to the nearest kilometers per hour. And if we go back to the question, well, that's what they asked, to the nearest kilometers per hour. Great. So that does it for question number 2. In the next video, we're going to take a look at question number 3, which has just a light bulb in a written section, and it looks like it's involving some functions. So, we'll take a look at that, but we'll do that next time.